Swayam Prabha. Digital India. Educated India.
Now, we will solve some example problems involving Mohs circle as well as a 3-dimensional state of stress to find the principal stresses, extremum shear stress and so on. Okay. The first problem will be a plane stress case, the second problem will be a 3-dimensional stress state. Example 1, let us assume that I have given you a state of stress, a plane state of stress represented like this. These are the coordinate systems. Let us assume that the stress is acting like this 10, 5, 10, Now, the question is what does this state of stress corresponds to? I want to write it in the matrix form. So, you find that in the area wherein the normal is pointing along the positive E x direction, you have distant stress pointing opposite to the positive coordinate direction. So, that will be a negative stress, that will be a negative sigma x x stress. So, that is minus 10. Similarly, in this 5 MPa stress, which is the shear stress, sigma x y stress is acting opposite to the y positive y direction on the face which has a positive normal oriented along the positive x direction. So, this is a negative shear stress. So, that will be minus 5 in there. I do not have sigma x z because it is a plane state of stress. Similarly, this will be minus 5. I do not have a sigma y y stress in there. So, that is 0, 0, 0, 0, 0. Okay. Now, for this state of stress I am interested in finding what are the principal stresses and maximum shear stress. Okay. To find the principal stress, I am interested in finding the principal stresses. You know that the principal stress sigma 1 is given by sigma x x plus sigma y y by 2 plus the radius of Mohs circle which is square root of sigma x x minus sigma y y by 2 whole square plus sigma x y whole square. Okay. So, now this will be sigma x x is minus 10, sigma y y is 0, this will be minus 10 plus 0 by 2 plus square root of minus 10 minus 0 by 2 the whole square plus minus 5 the whole square. Okay. So, this will be nothing but minus 5 plus or minus minus 5 plus square root of 25 plus 25 which is 5 root 2 minus 1 which will be 2.07. Okay. Now, similarly, sigma 2 is given by sigma x x plus sigma y y by 2 minus square root of sigma x x minus sigma y y by 2 the whole square plus sigma x y square. This will be 5 minus 5 into root 2 plus 1, okay, which will be 12.07 MPa. Okay. minus 12.07 MPa, which will be minus 12.07 MPa. Okay. So, having found the principal stresses, now you can find what will be the tau max, that is nothing but the radius of the Mohr circle, which is sigma x6 minus by 2 whole square plus sigma xy square, that is 5 times root 2, which will be 7.07. Okay. Now, we were interested in finding out at what plane these principal stresses occur. Next, we are interested in finding out the plane on which the principal stresses occur. Okay. Now, you know that tan of 2 times theta p is given by 2 times sigma xy divided by sigma xx minus sigma yy, which is 2 times now minus 5 divided by minus 10 minus 0. Okay. This is nothing but minus 1 by minus 1 plus 1. So, you might think that 2 theta is 45 degrees, right, but both the numerator and denominator has negative signs. So, you have to make your angle from vary from 0 to 360, which means this quadrant is where the tan is positive, this quadrant is also tan is positive, but in this quadrant both numerator and denominator would be positive, in this quadrant both numerator and denominator will be negative. So, what we want is you want this quadrant in here. So, it will be 180 plus 45 degrees, which will be 225 degrees. Okay. So, this will imply 2 theta p is tan inverse minus 1 by minus 1 is nothing but 180 plus 45 degrees, which is 225 degrees. Okay. So, theta p would be 112.5 degrees. Okay. So, if I were to represent this stress state in a Mohr circle, if I were to represent this stress state in a Mohr circle, here I plot taus of n versus sigmas of n. Okay. Now, sigma y is 0 and sigma x is minus 10, this is minus 10 say, and this is 0, and my shear is negative at sigma xx location, sigma in the x plane is negative, okay, which means I have to come down here and the shear in the y plane would be positive, because you are rotating the coordinate system by 90 degrees, which will be a 180 degree rotation, which will result in the shear stress at the y plane to be positive. So, and the center of the circle would be at 5 minus 5. So, this is the two stress states that you have 0 comma plus 5 and the stress state is minus 10 comma minus 5. Okay. Center of circle is minus 5 and when theta p is 112.5 or 225 degree rotation. So, now the principal plane is at an angle of 225 degrees, which means I have to go from here all the way to here. This is 2 theta p. Okay. So, and it is in that plane where the maximum normal stress occurs, which is this point, which we found it as 2.07 comma 0. Okay. The minimum will occur at 22.5 degrees, which is theta p minus 90, okay, or at 45 degrees in the Mohs circle. Okay. So, this angle gives you the minimum principal stress, which is minus 12.07 comma 0. Okay, the other extreme value of the normal stress. Second extreme value of the normal stress is given as 12.07 comma 0. Okay. So, that is that plane. Okay. Now, if I were to represent these planes in this stress cube itself, I have E y, E x acting like this, theta p 112.5, which results in the maximum principal stress is occurring at an angle E x star, E y star, where this angle is this theta p, which is 112.5 degrees. Okay. This is where 2.07 stress occurs. Okay. So, if I were to draw the stress square, this stress is 2.07, okay, and this stress in here would be 12.07, okay. That stress in there will be 12.07, which will be at 45 degrees to this inclined E x rotated by 45 degrees will be that minus 12.07 stress occurring direction. Okay. Okay. Now, the next thing I want to find is plane on which the maximum shear stress occurs. Okay. Now, you know that plane would be this vertical line. Okay. So, this angle is 45 degrees, this angle is 45 degrees. So, this angle will also be 45 degrees. Okay. From the expression you know that tan 2 theta s is sigma y y minus sigma x x divided by sigma x y to sigma x y. Okay. So, this will be 0 plus 10 divided by 2 into minus 5. So, this is 10 by minus 10. Now, the denominator is negative, which means the denominator is negative, it means you have to be in the second quadrant, which means 2 theta s is going to be 90 plus 45 degrees, which is 135 degrees. Okay. So, theta s would be, this implies theta s is going to be 135 degrees divided by 2, this value is 67.5 degrees. the maximum shear stress need not occur only in this plane, but it will occur in planes which are 90 degrees plus this angle also, because shear stress will occur in pairs, both sigma xy and yx are same. So, they will be occurring at 4 planes wherein this maximum shear stress will occur. Okay. To represent this maximum shear stress, the same orientation of from with respect to the original stress square, it is going to be 67.5 is somewhere here. This will be E x tilde wherein the maximum shear stress occurs, and this will be E y tilde, and this angle is theta s, which is 67.5 degrees. Okay. We will move on to the next example, wherein say I have a 3-dimensional stress state where sigma is given by this. I am interested in finding out the principal stresses and principal planes. Stress and planes I want to find. So, to find the principal stress I have to find the characteristic equation. The characteristic equation is given by lambda cube minus trace of sigma lambda square plus 1 half trace sigma squared minus trace of sigma square into lambda minus determinant of sigma must be equal to 0. Okay. From this stress tensor you find the trace of sigma is minus 10 plus 10, which is 0, and similarly you can find determinant of sigma to be 250, which will be nothing but 5 into 0 plus 5 into 10. Okay. Doing about this third row second column as a pivot element, because that is the only non-zero element in that row. Okay. So, that will be 250. I can find sigma square as, given the sigma, I can find sigma square as 125, 0, 25, 0, 150, 50, 25, 50, 25, okay, which will be nothing but 10 square plus 5 square minus 10 into 5 plus 5 into 10 and 5 square and so on. Okay. Now, from here I can find trace of sigma square to be 300. Okay. So, my characteristic equation will reduce to, so my this characteristic equation will reduce to lambda cube plus 1 half minus 300 lambda minus 250 equal to 0. Okay. Now, this cubic equation can be solved to get the principal values as, from here we will get the principal value lambda 1 to be 13.01, lambda 2 to be minus 1.7 and lambda 3 to be minus 11.3 MPa. Okay. So, these represents the principal stresses. To find the principal directions, I will illustrate it using finding only one principal direction. The other two you can follow the same procedure to get the other two principal directions. Okay. Now, to get the principal direction, I have to write sigma minus lambda 1 identity into n 1, which is the principal direction 1 corresponding to this eigenvalue or the principal value lambda 1, this should be equal to 0 vector. Okay. So, 13.01, this will give me 10 minus 10 minus 13.01, 5 0 5 10 minus 13.01, 5 0 5 minus 13.01, 0 minus 13.01 into n 1 x, n 1 y to n 1 z, this must be equal to 0 0 0, right. This will imply that I have minus 23.01, 5 0 5 minus 3.01, 5 0 5 minus 13.01 into n 1 x, n 1 y, n 1 z must be equal to 0 0 0. Okay. I can't invert this matrix because as we saw determinant of this matrix is 0, determinant of this matrix is 0, that is how we found lambda 1. So, I have to resort to solving this, writing it in terms of n y in terms of n x 1 or n g 1 and then use the fact that n x 1 squared plus n 1 y squared plus n 1 z squared is equal to 1 to solve for the unknown variable in there. Okay. Now, let us proceed and do that. From this third equation, I can write n y 1 as 13.01 by 5 n z 1, and from the first equation I can write n x 1 as 5 by 23.01, n y 1 which is 13.01 divided by 5 into n z 1 which is nothing but 13.01 divided by 23.01 into n z 1. Okay. Okay. Now, then I substitute back in this quadratic equation to get the equation 13.01 by 23.01 whole squared plus 13.01 by 5 whole squared plus 1 into n z 1 squared is equal to 1. Okay. From here I get n z 1 to be 1 divided by 13.01 by 23.01 whole squared plus 13.01 by 5 whole squared plus 1 power half plus or minus. Okay. So, from here I get n z to be plus or minus 0.351. Okay. Similarly, I substitute back this in here to get n x 1 as 0.199 and n y 1 to be 0.915. Okay. Okay. So, now plus or minus for each of these cases. So, there are different possibilities of combinations of values, wherein I can take the plus sign for all or negative sign for all, which will represent the two opposite faces of the stress cube, wherein the stress will remain the same. So, both of them are equivalent representation of the same plane. Okay. I can take this as n z1 or I can take this as n z1, right. Both of them are equal in magnitude, but opposite in direction, the stresses will be the same. Okay. So, that is what you have this plus or minus coming in there. Okay. So, this is the way you find the principal directions. Similarly, you can substitute instead of lambda 1 lambda 2 and you can find the other two principal directions. Okay. We will stop here.